Okay, so in this video we're going to be discussing the malate shuttle and the glycerol shuttle. So we said before that NADH can participate in the electron transport chain in order to produce ATP. Now NADH is mostly synthesized by the TCA cycle inside the mitochondria, but NADH could also be produced by the process of glycolysis that happens in the cytosol. So in order for NADH to participate in the electron transport chain, it needs to be able to enter the mitochondria. So how does this happen? Well, there are two ways for NADH to enter the mitochondria. The first way is by using the malate shuttle, and the second is by the glycerol phosphate shuttle. Okay, so we're going to start by discussing NADH transport via the malate shuttle. So, like we said before, NADH needs to be transported inside the mitochondria in order to participate in the electron transport chain where it can produce ATP. Now, the problem is that NADH cannot go through the mitochondrial membrane. It's not permeable to it. So the way that we transport NADH into the mitochondria is by using a shuttle. This shuttle is called the malate shuttle. Okay, so how does this happen? So we're going to start with a molecule of oxaloacetate that's located in the cytosol. Oxaloacetate is going to be converted into malate, and in the process it's going to consume one molecule of NADH and produce one molecule of NAD+. Malate has the ability to go through the malate shuttle. So once malate enters the mitochondria, it's going to be converted back into oxaloacetate, and in the process, it's going to consume one molecule of NADH and of NAD+ and produce a molecule of NADH. So basically, we have now transported NADH from the cytosol into the mitochondria. NADH now has the ability to enter the electron transport chain and produce ATP. Okay, so the second way in which we can transport NADH from the cytosol into the mitochondria is by using something called the glycerol phosphate shuttle. Okay, so here we're going to use the enzyme glycerol phosphate dehydrogenase. Now, this enzyme, one of them is going to be located in the cytosol, and the other is going to be located on the mitochondrial membrane. Now, these are the same enzyme, and basically they can catalyze a reversible reaction. So let's dive into a little bit more detail. So dihydroxyacetone phosphate is going to be converted into glycerol phosphate by the cytosolic glycerol phosphate dehydrogenase. And in the process, it's going to consume one molecule of NADH and convert it into NAD+. So this glycerol phosphate is going to go close to the mitochondrial membrane, and it's going to be worked on by the glycerol phosphate dehydrogenase that's located on the mitochondrial membrane, and it's going to be converted back into dihydroxyacetone phosphate. And in the process, it's going to produce one molecule of FADH2. Now, like you can see, we've transported NADH into the mitochondria in the form of FADH2. Now, it's not the same NADH, it's FADH2, but they have the same function, which is basically electron carriers.